Hello, the following is a recording of our AI and Tourette webinar with child psychologist Dr. Christine Conelea. Our team, the Mintic Lab, hosted this webinar on January 16th, 2025. Hope you enjoy it.
We're really a wonderful team of a lot of scientists and researchers that are really excited about partnering with the Tourette community to help make sure our science is answering questions that are important to the community. And so this project really, this direction our lab has taken really came out of conversations that we were having with the Tourette community about challenges that they were facing in their care. So I'll dive right in, just to level set us about what tics are. So tics are these involuntary, repetitive, very frequent movements and or sounds. We know that tics tend to start earlier in childhood with simple movements of the face. This will be relevant for later. So typically starting with things like eye tics, like hard eye blinking or eye rolling, and then moving to other facial movements. And then in some cases, progressing out into the periphery of the body. And then some folks also develop sound or vocal tics that can include sniffing, throat clearing, all the way up to more complex things like words or phrases. And so we think of Tourette syndrome, the technical meaning of that diagnosis is that a person has both motor and vocal tics over the course of their experience, and they've had them for a year, but tics themselves can occur in alongside a lot of diagnoses. They can be more transient. These are all important things as we get to thinking about diagnosis and treatment. And so, I'm a clinical psychologist by training, and whenever as a clinician we're thinking about care for any kind of patient, or whether it's tics or something else, there are two key components of our care. And so one is diagnosis, so trying to make sure that we're identifying the right name, the right label for the problem the patient is having, because that helps us understand what the right treatment is. And for Tourette syndrome and tics, and for all psychiatric mental health conditions, what's interesting is we don't actually have any kind of lab test that tells us if someone's movements are tic or not. So how we currently get to a diagnosis is we do a clinical interview with the patient. So a clinician, gets a history from the person having the tics, maybe a family member as well, and then they're watching during the visit to also try to see what kinds of tics they seem to be experiencing. And so this is kind of like an analogy to this is thinking about like when someone reports like, oh, I think I feel hot, I might have a fever. Kind of where we're at right now is we only have like the hand to the forehead of like, yeah, it feels warm or it doesn't. We don't have a thermometer, like something that kind of gives us a clear numerical value that tells us like, yes or no, this person has tics. So sometimes people do have lab tests like a brain MRI or an EEG, but usually those are used to make sure that it's not a different diagnosis causing the movements, but it doesn't say for sure that someone has Tourette's. Our current treatments, the first line gold standard treatment for tics is a treatment called Comprehensive Behavioral Intervention for Tics, or CBIT. And this is about 8 to 10 session therapy that's delivered by a trained therapist that focuses on teaching patients skills to manage tics. And so a major problem in tic care that I see in my own clinical world and hear about all the time from people we work with in the community and that we talk to with tics is like, there are major problems with access. And so a major problem is that both of these are really dependent on a human. So particularly in Tourette's, we're reliant on what we think of as kind of a specialist or a subspecialist. Like most primary care providers, family medicine docs, pediatricians, et cetera, they maybe at best get one lecture on what Tourette's is because they have to learn a lot of things. So they have to know a little about a lot of things. Specialists know a lot about a few things. But this creates really big bottlenecks in people's ability to access care. So, for example, we know that at least half of pediatric Tourette cases are undiagnosed, and there are even higher rates of undiagnosis among youth who are from minoritized ethno-racial backgrounds. So, kids who identify as Black, as Hispanic, those kids are not getting diagnosed as much. And then even when diagnosis happens, and maybe some of you have had this experience, but a lot of people have stories of how long it took to get to the diagnosis from the time symptoms start. And so there's been research on this, and the range that people typically report is somewhere in the order of 3 to 11 years between onset of symptoms and diagnosis. So imagine if that was the case for like heart disease or cancer, that we'd say, well, it's going to take us about 11 years to get you your diagnosis. This is a huge bottleneck, and it's a missed opportunity for people to get treatment that might be helpful. So then, okay, there's this bottleneck to get to treatment. And then if you're fortunate enough to get a diagnosis, there's another bottleneck when it comes to getting something like CBIT. And so at best, what we think is that about only 30% of people who are diagnosed actually receive CBIT. And a lot of the barriers that people have told us about have to do with this provider gap. So there might not be a provider or one in your area. Waiting lists are really long. It can be expensive because it might not be that the provider's in network. And this reliance on humans also presents a big concern for two metrics that a lot of us in healthcare really care about, which is accuracy and quality. And so accuracy is this idea of like, we want to be right when we give someone that diagnosis. And with Tourette's, we also know that 80% of people who have Tourette's are going to have another psychiatric diagnosis too. And so we really want to be right in getting the diagnosis right and understanding like what is the full diagnostic picture of a person. But again, because we don't have a lab test for it, the clinician is entirely dependent on a patient's self-report, on what they're seeing, on their own interpretation. And so unfortunately, these are pretty subjective factors. So like, for example, identifying tic symptoms can be really hard for patients. Like if I asked you right now to tell me how many times did you blink your eyes in the past 5 minutes, it would probably be pretty hard for all of us to be accurate. And that's can be the experience of people with tics. We know these are like on average, people are having tics about 8 times a minute. So that's pretty hard to be accurate about. One of the things we also are finding in our work is that the clinical interaction, so just being in a clinical visit with a provider impacts tics. So what this is just showing you, I know it looks complicated, but we measured, so we actually watched videos of kids during appointments with a clinician who is evaluating them, and then while kids were alone. And so these blocks over here are all when a kid was alone. And I really want to highlight this bar and these ones over here. So what we're finding is that the average number of tics kids are having when they're alone is about 25 a minute. But when they're in front of a clinician, even talking about their tics, we're only seeing 5, 3, and then this is talking about mental health symptoms about 3. So what clinicians are seeing in a visit often doesn't represent what the symptoms really are. And, if some of you are, parents or people with tics, like you might have this experience of like, they're ticking all the time. I tick all the time at home, and then I get to the doctor's office and I don't tick, and they don't like believe me. And this is a real effect that setting has on tics. And so, what do clinicians do when we don't have a lab test? And we do something called, we rely on something called a heuristic. So this is a psychology term that basically means a mental shortcut. And so we all have heuristics. So these are kind of simple rules that we build in our head to try to make it easier for us to make a decision fast. And so when you're a clinician and you're learning about how to diagnose Tourette's, you learn heuristics. So you kind of learn, here are the typical symptoms that you'll see when someone has this diagnosis. Like they'll have these kind of tics in this kind of place and this frequent, and they'll tell you this kind of a history. But what we also know is not every patient has the same experience. And so some people who have tics have different experiences, have different symptoms. And so all of these things can make it more cloudy for clinicians and to really help make sure they're getting to that right diagnosis. And then when we come to therapy, the challenge can sort of be around, you know, therapists. It's not like a medication where we can sort of say like, okay, we know if we make this medication this way, it's the same dose every time. The therapist, like when I'm a therapist, I am the treatment. I am the treatment ingredient. And so it's really reliant on my decisions about, okay, the kid that my patient just said this, like, what do I say next that's going to be the most helpful thing to say? So these are hard things to have good quality around. So how does AI fit into all of this? Fun fact, I generated this image with AI. So, it's kind of all around us right now and in the news. And so I want to just um, make sure I'm talking about how we're using it. And again, here's another thing I made with AI, with Chat GPT. It said, make me a 2-column chart of what AI is and what AI is not. But from my perspective as a researcher and how I've been working and talking a lot with a lot of really thoughtful scientists who are in this space of thinking about how AI could improve healthcare. And I really want to emphasize a few things on here. Like, we think of it as a tool that can help clinicians make decisions that might be more accurate more quickly. Kind of like the thermometer is a tool. Can we use tools to reduce clinicians all these sources of error or reduce their chances of missing something that might be there? We're not trying to replace people. I'm a clinician. I don't want a computer to take my job, and I don't think that that's really where the vision is of where these are going. And so these are based on data. And again, it's really this assistant to humans that is kind of the direction that we're thinking about it. And the reason that's helpful is, as humans, it can be hard to process all of the information that we may be getting in a clinical visit and come out to the right thing, whereas a computer doesn't get as tired about holding as many things in its head. So it can kind of help us catch things that we might otherwise miss. And so in my lab, we've been really interested in this question of, can we've been looking for tics in videos as part of our research for really the last 20 years. So I'll talk about how we do that. It's really, really tedious to watch a video and count every tic that happens in it. But we also have lots of data, like the ones I showed you, that when we do that, we actually get really different answers than when we just try to ask people, like, how many times did you tic? So it's kind of getting closer to that, like, thermometer, a number value. And so we've asked the question, given that we can see a lot of tics on video, can we train an algorithm to identify those tics as a way of improving diagnosis and measuring how severe someone's symptoms are? And so just to kind of level set on, what do I mean when I'm talking about an algorithm and AI? So this is really a concept between a type of AI called supervised machine learning. And it's really more simple than all the things will make you think. And what it's doing is, first of all, it depends on really good data. So, if you have bad data, you'll have bad algorithms. But if you have good data, and what that means is you have information that you have labeled. So like, this is a good example. You have all these shapes that are in this blue square, and then you have someone go through and they label which shape is which. So think of these, like, for us, this might be like motor tics, vocal tics, compulsions. Like, we're trying to identify so we label those behaviors as humans who are the researchers. And then what we can do is take that labeled data and we put it into the computer model. And then it's using all the information from those labels to learn what kind of features that we are using to make our decisions. So probably the computer in this case would learn something like, okay, when something has 3 sides, it's a triangle. And then so it's going to make a prediction like that, like, okay, I'm looking at a 3-sided shape. I think it's a triangle. So we would test that algorithm on some data that it's never seen before, and then that will tell us if it's accurate or not. And so this is really the approach we're using to try to understand how to detect ticks in video. And so how do we do this? How do we make sure we have good data? And this, is a paper that our lab did recently that really tried to set the standard for the field around how we make good data that we can trust so that we have algorithms that we can trust. And what we do is we have folks with ticks who participate in our research do something we call it the tick task. And so we're doing a video recording of ticks, and we ask people to do one of 2 things. So it's brief. These are 3-minute clips. And in the first 3 minutes, we just ask people, let your ticks happen naturally. And then the second 3 minutes, we're asking people to just try to stop them or try to control them. And so this is how we can kind of see, like, what do ticks look like when they're just happening, and what do they look like if someone is trying on purpose to inhibit them. And so this lets us get a snapshot of what someone's ticks might look like in their life. And then we can also do things like have them say how strong their urge to tick is during the video clips. And then we take those clips. This is me just demoing here. And then this is just to show you how it's a lot of work, but we have a computer program that we as humans use. And so we watch these videos, and then basically every time we see a tick in the video, we're using the software to mark that spot in the video and to say what we saw. So like right here, you're seeing like I pause the video and I'm marking that at this time point in the video, I saw an eye tick. And my lab, bless their hearts, have coded over thousands of these already. It's a ton of work. But what it does give us is this quality data that we can trust that helps us use these machine learning approaches. And so in a recent study we took 54 videos of this from 11 participants who had come through one of our studies. And sorry, this was supposed to have more pictures or something. So we took those videos, and then we have some wonderful collaborators who are computer scientists at the University of Minnesota, whose expertise is in like how do you use computers to pull information out of videos. And what we did is something called we encoded the data. So you can see we're kind of like stripping out the face, and what we're doing is it's almost like a digital mesh. Like we put like a mesh on top of the face that creates lots of different points over the face so that we can use each of those points to track how the face is moving over time. And so this is an example of what that looks like with a clip of, let's see if it works. There we go. It's a little glitchy. Let's try it again. I guess that kind of worked. There we go. So that's a clip where someone's not having a tick. And here's a clip where they are, an eye tick. So you can see like those data points are enough for us to be able to see, you can see the difference between when someone is having a tick and not. And so in this study, it was really our first try, and there's not many teams doing this to do this. So we really focused just on eye ticks because 98% of people with ticks have eye ticks. So we're like, let's tackle the most common tick first. And so we took this information and we trained an algorithm, and then we showed the algorithm or our computer videos it had never seen before. And then we asked it, can you tell us how many eye ticks are in this video? And we compared it to the numbers that we as researchers coded. And so this is just to show you that there are numbers to this. Basically, this is the kind of graph that gets made whenever you're making a medical test that tells you how accurate that test is at classifying correctly. So like it's saying like, yes, this is a tick, or no, this isn't a tick. So that blue line is chance. So that would be like if it performed entirely at chance, it would be there. And so we want to see something like this. So what this is telling us, this is about 90% accuracy at classifying and counting eye ticks. And so that paper is published. We were really excited about it, but we only did eye ticks, and we want to be able to detect other kinds of ticks, and we want to be able to make sure that we're accurate. And one of the tricks to doing AI and algorithm training is you really do need a lot of data to feel confident that your algorithm is correct and that it works across people. Like if all I did was train my algorithm on me, it's only going to be able to identify things I do. We really want it to identify it across everyone who has tics. And so we were fortunate to be awarded a grant from the National Institute of Neurological Disorders and Stroke to be able to do that. And so we're currently doing a study we call Tic Clips. And so we took this whole idea of getting videos and said, why don't we just make this easy for the Tourette community to do? We heard a lot of people like, we want to participate, but we don't live in Minnesota. So we put everything online. And so it's an entirely online study that lets people, when you join the study, you have an opportunity to give us a little bit of information about tics, like what tics there are, and then to submit video clips so that we can have more, not just more data of these, but we want more data from more people so we can really make sure that everyone in the Tourette community is represented in terms of, age, gender, geographic location, ethnicity. So if you or anyone is interested, this is a great way to help us help you build these diagnostic tools. I will quickly pivot to treatment just so that we have time for questions. But we're also really interested in, can we train an algorithm to help us with how address this problem of therapists? There's never going to be enough therapists to do CBIT. That's just like in all of mental health, that's sort of the reality we're all kind of coming to realize, is that we're always going to have more demand than we have providers. And so can we have tools that help us train providers faster so they can start to see patients sooner? Can we monitor their quality? Can we maybe build tools that don't rely on a therapist in the moment to help support you in what you're going through? And so we're in the early stages of working on this using another kind of AI called natural language processing. So this is sort of similar to what I talked about with machine learning, but instead of basing it on like numbers, it's basing it on language. And so what natural language processing does is it's an analysis approach where the computer is looking for things like, what are the words being said and what do they mean? How does a conversation go back and forth between two people? Are the words like describing like positive emotions or frustration? So it's able to kind of take all of the ways that we naturally talk and analyze that. So probably all of us have interacted with natural language processing models. If you've ever talked to Siri or to your speaker, or used ChatGPT, or when you're typing in Google and it predicts your text, this is all natural language processing that is informing that. And so, we want to get good data. So what we're working on in the lab is taking transcripts of conversations that happen during CBIT sessions. And similar to the coding, we have to be able to tell the computer, like, what is happening that you need to know. And what we're interested in is helping the computer learn what topic is being discussed in the session. So we're going through these transcripts and we're marking up, this is the topic of the conversation. And then we'll be able to look at, when different kinds of conversations happen, how does that relate to, the patients that get better, the patients that don't? Is there a way we can teach therapists how to do it in ways that are more effective? And we were just, as of last Friday, awarded a new grant from the Data Science Institute at the University of Minnesota to keep this work going with some colleagues who are experts in natural language processing. So something we're very excited to do. And so just, stepping back and again, thinking about the future, where we're going, and this is really me talking as a clinician who is, working in these systems and as a scientist, and from all the things we've heard from our conversations with the Tourette community. What I'm really envisioning with this space is that these are tools that, again, they won't replace clinicians, but they'll really enhance our clinical ability to scale up access. So for example, if we have a video-based tool, maybe we could get a lot better at flagging which kids have tics earlier in development. Maybe we can have a better tool for really measuring how well a treatment that they're doing is working. We could use it when we're testing new treatments in clinical trials to make sure that we're right when we say we think something works. With treatment, some of these, models could help us do things like, could we have a CBIT chatbot that maybe is a first level of care? Well, you're waiting on a wait list. Maybe some people that's enough and they don't need a therapist. Maybe you could do that and then work with the therapist to just refine your skills. Can we, there are people in other therapies who are doing things like this to monitor how well therapists are doing so we can make sure we're doing the best care we can to train us to be better at learning new therapies. So I think it's a really exciting place to be and to really think about how technology can play a role in making care more accessible to more people. And with that, I'll just, I'll thank the lab. All of this is done with a huge village of people with expertise in so many different things. And I'm really grateful to everyone for being a part of that. And I wanted to plug again what Carolyn brought up at the beginning with our newsletter. This is just quarterly. We don't flood your inbox. But it's a way for us to be able to continue to connect and communicate with you what we're doing in the lab, what we're learning in the bigger field of Tourette science, and also a way for you to stay connected. And we love to hear from you in the community about, what issues you're facing, what questions you wish researchers would look at. So it's a great way for us to just be able to have those two-way conversations.